Cathode Ray Oscilloscope. This is the device which is used to display waveforms of various electrical signal, both AC and DC, in the same way sound signal. So there are different types of CROs available. The short form of cathode ray oscilloscope is CRO, and it is the device. It is a versatile electrical instrument used for displaying, measuring, and analyzing waveforms and various other electrical phenomena. It functions as a fast XY plotter, displaying input signals versus time or other signals. We can find out the frequency of the wave, we can find out the amplitude, voltage, etc. What are the uses of CRO? It is used to study waveforms of various types. It is often used as a voltmeter, and it can measure both AC and DC with high degree of accuracy. It is used to measure frequency and time period of all types of waves. Circuit symbol for CRO. This is a circuit symbol when circuit diagram is drawn in which CRO is connected. So this will be the symbol which will be drawn. And it is connected in parallel to the component whose potential difference or voltage is to be found out. Thermionic emission. This is the basic principle on which CRO works, that is the emission of electron from the hot metal surface. So when metal is heated up to a high temperature, the thermal energy of the metal gives some of its electron enough kinetic energy to escape the metal's surface. So CRO uses an electron beam because so many electrons appear and they move in the form of a beam, and this may be made to accelerate towards the screen of the CRO. The CRT is a display tube that functions as a heart of CRO. The construction of CRO includes the following: cathode ray tube, which is evacuated, electron gun assembly, consists of cathode and anode, and grid, deflecting plates, which will be causing it to show the trace along x and y axis, fluorescent screen, where electrons strike and their kinetic energy appears in the form of bright spot or a line or a wave. So we call that appearance a trace. We call it trace. Beside this, a glass envelope. So the assembly, this cathode ray tube is evacuated tube because electrons should travel without any hindrance towards the screen. They should not be deflected due to the collision with the air molecules. So here, this is the filament which is used to heat up the cathode. Cathode is at negative potential. So heating up of the cathode will cause electrons to be emitted out of the metal surface. These electrons will form a cloud near the surface of the cathode. So this should not happen. In order to make it move forward in the form of a beam, there should be some positive terminal attached. So that is in the form of anode. So this anode is at positive potential with respect to cathode, and the potential difference between cathode and anode is about 2000 volt to 5000 volt. So this is cylindrical shape. So it means electrons will go straight passing through the anode and they will strike the screen. When they strike the screen, their kinetic energy appears in the form of light and little heat as well. So this is the bright spot which appears in the middle of the screen, because right now there are no deflection plates attached or no connections are given to those deflection plates. So these two plates are X plates because they will cause the horizontal movement of the beam. Beam will be deflected towards right or left along the x-axis depending on which plate is made positive, either right or left. So spot will appear on the right or left side of the screen due to the connections provided to X plates. In the same way, Y plates responsible for vertical movement of the electron beam. So when upper plate is made positive, the beam will deflect towards the positive because electrons carry negative charge. So if upper plate is made positive, the beam will deflect in the upward direction and spot will appear in the upper part on the upper part of the screen. When the lower plate is made positive, the beam will deflect downwards. So electron beam can be reflected in two directions, the horizontal or x direction and the vertical or y direction. So this produces a spot which can be seen on the screen. So right now spot appears in the middle. Why spot is appearing in the middle? Because deflection plates have no connections. Neither X plates have any connections nor Y plate. So the beam goes straight towards the center of the CRO screen. CRO screen has the division, the grid, and this is usually 1 centimeter width and length both, but this may vary also. So there are 5 divisions in between the two consecutive lines. So we can read the appropriate voltage according to the setting of time base or setting of Y input. So how to calculate the speed of electron in the beam? Electron accelerates in the field between the anode and cathode. So they lose potential energy and gain kinetic energy because they accelerate. So gain in kinetic energy is equal to loss in potential energy. We know the formula of kinetic energy, half mv square, and loss of electrical potential energy, that is given as E into V, charge into potential difference. So E is the charge on electron and V is the potential difference between cathode and anode. So now we are giving positive potential to upper Y plate and negative potential to lower Y plate. It means this will cause the beam to deflect in upward direction. So electron deflect in upward direction and spot appears on the upper part of the screen. So typically the x-axis of CRO represents the time while y-axis represents the input voltage signal. So we can find out what voltage is connected to the Y plates. The potential difference between Y plates, according to that potential difference and setting of the Y input, we can find out the position of the bright spot on the screen. Right now, this is in the middle when there is no connection given to any of the plates. So when we give positive potential to upper Y plate, the spot appears on the upper side. If we do the reverse, that is lower plate is made positive, the spot appears at the bottom of the screen. In the same way, we can have X plates also connected to positive and negative terminals. So right now, right side is positive and left side is negative. So what happens as a result? The spot will appear towards the right side because being negatively charged particles, electrons will deflect towards right. Right and left plates are X plates. In the same way, we can do the reverse. We can connect negative terminal to right side plate and positive terminal to left side plate. So what will happen? Spot will appear on the left side of the screen. Beside this is DC input. Okay, right now what we are showing DC input, but we can connect alternating supply also. That is sinusoidal voltage. So when we connect sinusoidal voltage to Y plates, what will happen? The beam will oscillate up and down depending on the input voltage. Okay, and the movement is so rapid, the bright line appears. This is the trace of the movement of electron beam. So the height depends upon the input voltage. In the same way, X plate may also be connected to alternating, that is sinusoidal voltage. So if this is done, the spot will oscillate from right to left or left to right. And the speed depends upon the setting, and in the same way, it also depends upon the frequency of the supply. So X plates are usually having internal connection. We call it time base. It controls how fast the bright spot moves from left to right or vice versa. So time base of cathode ray oscilloscope, that is CRO, is the preset time scale on the x-axis where 1 centimeter is equal to the time base. The time base signal in a CRO is a sawtooth waveform that varies linearly with time. The time base generator produces this signal, which is applied to the X plate in XY mode operation. So this is the sawtooth waveform. So when the X plates are connected to the alternating supply or time base is on, the horizontal line appears on the screen. And horizontal line here is appearing in the middle because no connections are given to Y plates. If upper Y plate is made positive, what will happen as a result? The horizontal line will shift upwards. Beam is oscillating along the horizontal as well as it has moved upward depending on the supply voltage to the upper Y plate, how much positive the upper plate is made. So right now, time base, which is sinusoidal sawtooth signal, so the beam is oscillating and giving horizontal line on the screen, and Y input is DC. So this beam, which is a horizontal line, is shifted upwards. If we reverse the connection, that is, if we make lower Y plate negative positive and upper plate negative, what happens as a result? The beam will shift downwards towards the positive terminal. How to measure the voltage using CRO? We have to count the number of divisions, note down the position of Y gain setting knob, and the unit is volt per division or volt per centimeter. The voltage of that input voltage supplied to the CRO is equal to number of divisions multiplied by volt per division value. That is the setting of Y gain control knob. If the input voltage signal applied to the y-axis of CRO is sinusoidally varying, and if x-axis represents the time axis, then the spot moves sinusoidally, and familiar sinusoidal waveform can be seen on the screen of the oscilloscope. So here we have this is Y gain setting. The unit is volt per centimeter. It can be volt per division also. One block is one division. One box is one division. And right now the setting is 1 volt per centimeter. 1 centimeter here represents 1 volt. And this is Y input. These are the uh, connections which we have to provide with any battery or any other circuit. Time base is right now on. So when time base is on, the horizontal line appears on the screen. If we connect in an input, that is a battery of 1.5 volt cell, that is the bright line, horizontal line is shifted upwards. So how do we note down the voltage? We multiply the number of boxes with Y gain setting. So Y gain setting is 1 volt per centimeter and the boxes are 1.5. So this is the position. So this is in the middle of the second box. So 1.5 volt is the voltage. So when we replace this with some other input like higher voltage, that is 12 volt. So 1 volt per centimeter setting will not do the job now. So we have to change the settings to see the voltage. So we can do what? 5 volt per centimeter will be appropriate for this purpose. So when 5 volt per setting is done, the spot, the bright line, horizontal line shifts upward. Why this is horizontal line? Because the time base is on. So when we measure any higher voltage, the spot or the bright line will move even upwards. And the horizontal line may change into bright spot if the time base is off. When we turn the time base off, the bright line will disappear and spot appears on the screen at the same position. For higher voltage, we have to change the Y gain setting to any higher voltage, like here. Suppose what is the voltage of the supply to which Y input is connected when this is 5 volt and the spot is appearing at the fourth block. So what will be the calculation? Number of boxes. We can see it again. 4 boxes. 1, 2, 3, 4, and Y gain setting is 50 volt per centimeter. So number of boxes 4. Y gain setting 50 volt per division. So Y input, number of boxes multiplied by Y gain setting. That is 4 times 50, 200 volt. We can use CRO to measure alternating voltage also. So here AC supply is connected and time base is on. So time base is on. The trace which appears on the screen is now sinusoidal. And one wave occupies 4 blocks here. And the height of the wave is, the amplitude of the wave, it is 2 blocks. We can take either positive peak or negative peak. Okay, both are occupying 2 blocks or 2 boxes. Setting is 5 volt. So we can calculate the voltage of the supply, that is Y gain setting 5 volt per centimeter multiplied by number of boxes. Number of boxes 2, so it means 10 volt. If any higher voltage is to be measured, then the setting is to be made to be changed. Like this voltage. So how much is the voltage? How do we calculate? We count the number of boxes and multiply by Y gain setting. And when time base is on, so wave is appearing. If we turn the time base off, what will happen? The vertical line will appear on the screen. This is the setting 50 volt per centimeter, and this is the waveform which is occupying 4 blocks. In upper part of the middle line or the lower part of the middle line, there are 4 blocks. 1, 2, 3, 4. 1, 2, 3, 4. Setting is 50 volt. And when we turn the time base off, the horizontal, this waveform will disappear and we will get a vertical line of the same peak value. 4 blocks, 4 boxes above the middle line, 4 boxes below the middle line. So how to measure the frequency using an oscilloscope? We find out the time period, time between two crests of the wave. This can be a sound wave as well and any electrical signal. Of course, when we speak on the microphone, sound signal converts into electrical signal, which is fed to CRO. So time between two successive crests. So suppose and frequency is equal to 1 upon time period and f is equal to 1 upon t. For example, if t is 0.05 seconds, so f is equal to 1 upon 0.05, that is 20 hertz. For frequency to be in hertz, time has to be in seconds. So here we see the time base setting knob. The unit will be time in seconds per centimeter, millisecond per centimeter, microsecond per centimeter, nanosecond per centimeter. So how to calculate the frequency? We have to count how many divisions of the x-axis make up one wave. Because for the time, we have time base turned on. And when time base is turned on, this is connected to X plates. So multiply the number of divisions by the time base setting to calculate the time period. And use the formula to find the frequency. So here this is the trace which appears on the screen, and horizontally it is occupying because we are finding out the frequency. So we have to check the horizontal axis. So one wave is occupying here 4 blocks. 1, 2, 3, 4 boxes. So, and time settings, time base setting is what is the time base setting? 10 millisecond per centimeter. 1 centimeter represents 10 milliseconds. So what do 4 boxes will show? They will show 4 times 10. That is the total time of one wave is 40 milliseconds. And the oscilloscope is a very fast device. It can display the periodic signal whose time period is very small in microsecond or in nanosecond as well. So all can be found out. So this is the wave, and it is occupying, we don't know the exact boundary of one complete wave. So what do we do in that case? We count the total number of waves with the clear boundary and total number of boxes. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes. And how many waves are there in these 10 boxes? 1, 2, 3, 4, 5, 6, 7, and this is half wave. 7.5 waves are occupying 10 boxes. So let us see how to find out the frequency of this wave. The time base setting is 100 nanosecond per centimeter. So number of boxes of one wave, 4. Time base setting, this is for the previous one. The lower frequency wave in which the time base setting was 10 millisecond per division. So total time of for one wave, number of boxes multiplied by time base setting. So 4 times 10 millisecond, 40 millisecond. And when we convert 40 millisecond into second, we have to divide it by 1000. So this is 0.040 seconds. So frequency is 1 upon 0.04. That is 25 hertz of the first trace, the blue trace. And the second trace, number of waves, because the boundary of one wave was not clear. So we have to see where the boundary is clear. So 10 boxes, 7.5 waves. Time base setting, 100 nanoseconds per centimeter for the second waveform, which was in red color. Total time, 100 multiplied by 10, that is 1000 nanosecond. Nanosecond is to be converted into second later on. So total time period is total time divided by number of waves. So 1000 nanosecond divided by 7.5. So answer is 133.3 nanosecond. And for the frequency to be in hertz, time has to be in seconds. So that will be 133.3 into 10 raised to the power minus 9 seconds, and frequency will be 1 upon t, that is 1 upon 133.3 into 10 to the power minus 9. The answer is 7.5 into 10 to the power 6 hertz, that is 7.5 megahertz. So this is all now, and we will inshallah meet each other with the next video, that is the questions on CRO. Allah Hafiz.